We're going to prove that the sine squared of 2x is equal to 4 cosine squared of x minus 4 cosine to the fourth of x. Here's the deal. We cannot assume this is true, meaning we cannot treat this statement as an equation, meaning that I cannot divide both sides by 4. Because by dividing both sides by 4, I'm treating it like an equation. So when I say you can't assume what you're trying to prove, that's what I mean. Do not treat it like an equation. Instead, what you should do in proper notation for what we're doing is draw a line down the center. You do your stuff over there, I do my stuff over here. If we happen to get the same thing, great, it's proven to be true. Now, all of these, when they say prove that they're true, they are true, you just have to prove it for yourself. So they're all rigged to work in your homework. Looking at these two sides, which one is the more complex? The right one. The reason you want to start with the right one is you can do more with it. So we're going to use method 1, which says start on one side and hope to end up with the other. So after a couple algebraic lines here, we hope to ended up with sine squared of 2x. All right, let's play with it. Working on the right-hand side, what could we do? Out a... Yeah, let's take out a 4 cosine squared of x. If we take out a 4 cosine squared of x, what are we left with? All right, great. So you take out a 4 cosine squared of x, none of that happened. And if you take out your 4 cosine squared of x, what are you left with? Class? There you go, 1 minus cosine squared of x. But what is 1 minus cosine squared of x? Sine squared of x. We're going to use a trick. Notice that 4 is 2 squared, and sine squared is sine being squared, and cosine squared is cosine being squared. So you could pull out a square. Now notice I said pull out a square. I did not say square root both sides. You cannot square root both sides because that would assume that's an equation. Now we're better. What is 2 sine of x cosine of x? Sine of 2x. The identity for double angle for sine is 2 sine theta, cosine theta, or x in this case. Well, now it's just notation. How else can you write sine of 2x quantity squared? Sine squared 2x. Does this equal the other side? Yep, yep. You're squaring the function, not the angle. Is that okay? If you are done with the proof, there's 2 ways you can identify it. Actually, 3. You can draw a little box with it filled in. That means the proof is done. That's level 1. Level 2 is you write QED with your pinky out because it's fancy, which I think stands for this proof is complete in whatever language that is. Sure. And then the third way is write this with a quill pen, seal it with one of those wax things, and mail it off to someone famous. Just like they did back in the day. So notice we did method 1 for this entire thing, but at this line right here, we had a little hitch. There was a trick there of pulling out a square, which may not be intuitive. So what we could have done is start to work with this other side, because then you could say the sine of 2x squared, rewrite it like that, and then you could say, oh, 2 sine of x Cosine of x is a double angle for sine. And then if you square everything, then according to method 2, you'd be fine because then you found a common expression on both sides. So we used method 1, but we could have switched over to method 2. And that's what you should do if you get to a point where you don't know where to go from there. Switch your method.